first of all, let me bring your attention to a very basic concept. What is the remainder that we get when we divide 15 by 6? 15 by 6. The quotient is 2 and the remainder that we get is 3. So what is the relation between the dividend, the divisor, the quotient and the remainder? It is that we can write 15 is equal to 6 into 2 plus 3. That is, we can write dividend is equal to divisor times quotient plus remainder. This is the general thing that we call in arithmetic. We can do this for polynomials also. Like for 2x cubed plus x square plus x. If I want to divide this polynomial by x, I can write it as 2x cubed by x plus x squared by x plus x by x. What do I get? I get 2x squared plus x plus 1. Right? We don't get a remainder here. So what do we write? We write 2x cubed plus x squared plus x is equal to x times 2x squared plus x plus 1. Similarly, if I want to divide 3x squared plus x plus 1 by x, I'll write 3x squared by x plus x by x plus 1 by x. 3x squared by x will give me 3x plus 1 and 1 by x. Here I cannot divide 1 by x. So we have a remainder here which is 1. So how do we write 3x squared plus x plus 1, which is our dividend? Our divisor was x and the question that we got was this 3x plus 1 and the remainder that we had was 1. So we can write 3x squared plus x plus 1 is equal to x times 3x plus 1 plus 1. But how do we proceed if our divisor is a binomial? That means, for example, let px be a polynomial 3x squared plus x minus 1 and qx be another polynomial x plus 1. And if I want to calculate px by qx, how do we do that? Well, it is quite simple. It is similar to the division of numbers. Like I will write x plus 1 here and 3x squared plus x minus 1. This is what we used to write for numbers. So first of all, while dividing this, I will take the first term from here and the first term from here. Let me write it separately. 3x squared. I'll write 3x squared divided by x. What do I get? I get 3x. So I'll write 3x here. on top. And then I multiply 3x with this binomial. I get 3x squared plus 3x. Whatever I get by multiplying this binomial, I'll subtract it from the previous derivative. And by subtracting it, we get a new derivative, which is minus 2x. Not only minus 2x is our new derivative, we will also carry forward this minus 1 derivative. So minus 2x minus 1 is our new derivative. Again, we'll take the first term from here and the first term from here. Minus 2x by x. What do we get? We get minus 2. So I'll write minus 2 over here and then multiply with this binomial. I'll write minus 2x minus 2 and then I subtract these terms. By subtracting, what do I get? I get 1. 1 is remaining here. 1 is a new derivative. But as you see, 1 has a degree of 0. 1 is also a polynomial with a degree 0. And this is a polynomial with degree 1. So whenever the degree here becomes less than that degree of our divisor, we stop our division then and there. The remaining term is our remainder. So px divided by qx gives a quotient of 3x minus 2 and the remainder is 1. So we write 3x squared plus x minus 1 divided by x plus 1 is equal to, we'll write it here. 3x squared plus x minus 1 is equal to x plus 1 times 3x minus 2 plus 1. So 3x squared plus x minus 1 is equal to x plus 1 into 3x minus 2 plus 1. Now let us come to remainder theorem. Let px be a polynomial whose degree is greater than or equal to 1 and a be any real number. If a is a real number and if px is divided by x minus a, if px is divided by x minus a, then the remainder theorem says that we get a remainder of pa. That is, the remainder theorem states that if px is a polynomial whose degree is greater than or equal to 1 and if a is a real number and if px is divided by x minus a, then we get a remainder of pa. The proof is pretty simple. Let us assume that when px is divided by x minus a, we get a quotient qx. So we can write px is equal to x minus a times qx plus the remainder. Let the remainder be rx. Here our divisor is x minus a, which is a polynomial of degree 1, and the remainder will have a degree less than the degree of our divisor. So if the degree of divisor is 1, so the degree of the remainder would be 0. That means the remainder would be constant. Let that constant be equal to r. So we can write px is equal to x minus a times qx plus r. And if I put a instead of x in this equation, we get p of a is equal to a minus a times qx plus r. So we get r is equal to pa. Hence the remainder theorem is true. That is, when we divide a polynomial px by x minus a, then we get a remainder of pa. For example, find the remainder when 3x squared plus x minus 1 is divided by x plus 1 without actually dividing. So what would we do is let dx be equal to 3x squared plus x minus 1. Here it is being divided by x plus 1. So here the value of a is minus 1. You see that x plus 1 can be written as x minus 1. So the value of a here is minus 1. So our remainder is p of a. So in this case our remainder would be p of minus 1, which is 3 times minus 1 square plus minus 1 minus 1. This would give us 3 minus 1 minus 1, which is equal to 1. So the remainder when 3x square plus x minus 1 is divided by x plus 1 is 1. You can verify this, as previously in this video we had calculated the remainder by actually dividing and we got the same remainder 1. Hence the remainder theorem is also verified. Let us solve another example in which q of t is equal to 4t cube plus 4t square minus t minus 1, and we have to check that whether 2t plus 1 is a multiple of qt. So how do we do that? We know that if 2t plus 1 is a multiple of qt, then when qt is divided by 2t plus 1, the remainder should be 0. So we apply remainder theorem here. We put 2t plus 1 equal to 0. So here our a is minus half. So for calculating the remainder, we will put q of minus half is equal to 4 times minus half cube plus 4 times minus half square minus minus half minus 1. This would give us minus 2 plus 1. No, this would give us minus half plus 1 plus 1 by 2 minus 1, which is equal to 0. So q of minus half is equal to 0. That is, the remainder when qt is divided by 2t plus 1 is 0. Hence, we have shown that 2t plus 1 divides qt. That is, qt is a multiple of 2t plus 1. Now let's come to the factor theorem. For the factor theorem, we again have a polynomial px whose degree is greater than or equal to 1, and it is being divided by x minus a, where a is a constant, real number. So the factor theorem says that if x minus a is a factor of px, then p of a would be equal to 0. The converse is also true. That is, if px is divided by x minus a and if pa is equal to 0, then x minus a is a factor of px. The proof is simple and can be derived from the remainder theorem itself. The remainder theorem would say that px is equal to x minus a times qx plus pa, where qx is the quotient. So if x minus a is a factor of px, then the remainder must be 0, and the remainder is pa. So if x minus a is a factor of px, then pa is equal to 0. Similarly, if we have pa is equal to 0, then if pa is equal to 0, then the remainder is equal to 0. And if the remainder is equal to 0, then x minus a is a factor of px. Hence, the factor theorem is proved. So let us do an example on factor theorem. Find k if x minus 1 is a factor of 4x cubed plus 3x squared minus 4x plus k. We have to find k, and we have been given that x minus 1 is a factor of this polynomial. So if x minus 1 is a factor of this polynomial, let this polynomial be equal to px. So by the factor theorem, we can say that p of 1 would be equal to 0. That is 4 times 1 cube plus 3 times 1 square minus 4 times 1 plus k is equal to 0. That is 4 plus 3 minus 4 plus k is equal to 0. That is k